Hey everybody, moving into the second part of 11-1, we're going to talk about permutations and combinations. Now this is where the curriculum actually wanted us to start. Yesterday we talked about fundamental counting principle. I just thought it'd be good to kind of introduce that again from Algebra 1. So today we're actually moving into the Algebra 2 part of it. So it's very important that as we proceed on today that you understand the difference between the problems, like which one's fundamental counting principle, what's a permutation versus a combination. So fundamental counting principle, we already talked about. It's like outfits or passwords or PIN numbers or phone numbers, license plates, different things that you put, or meals, um, different things you put together. Like if you're picking a pizza and you have to pick a different crust and a different topping and a different type of cheese. All of those come together to be fundamental counting principle. Now, sometimes we deal with things that have to go in a specific order. Like let's say we have a group and we have to pull things from that group and put them in order. That's a permutation. Things like seating chart. I have a group of students and I have to put every single one of them in order. Or maybe I have a group of 10 people and I have to hand out a gold, a silver, and a bronze. That would be a specific order. Or let's say I have a group of 50 people and I have four specific jobs that need to be done. So how many ways can I assign those jobs? That's a permutation. And then we move to a combination. A combination is just groups. You're still having like an overall group, like maybe you have 50 people, but you're just looking to pick four of them. Not for anything like specific different, but like maybe you just need four people to help you do the same job. Or it's like you have a group, but the four or the five or the six or all 50, however you're picking out, it doesn't really matter the order in which you pick it. So I try to, like if you have like 12 different toppings on a pizza and you want to pick three of them, that's a combination because you don't really care about the order that you put the toppings on your pizza. You just care about like the different ones that are going on your pizza. So there are these really crazy formulas for permutation and combination. I promise they look a lot more intimidating than what they actually are. This is the formula, and this is like the precursor. N is how many items you have. So let's label that. So this is a permutation, capital P. This is how many you have. So how many total? And then R is how many you want. And I'm going to put you want to order because like order is super important. And then that's the same for combination too. So what you need to see is that combination and permutation are literally almost identical to each other, but because combination of the same amount of items will always be smaller than permutation of the same amount of items because you're not cared about the order of those groups, you have to divide by this extra R down here. Now, some of you might be looking at this and be like, wow, like she's really excited about math. Look at the use of that explanation point. That's not an explanation point. That's called factorial. And let's just talk about factorial in case you forget. Factorial, let's write that down. Factorial. Factorial means you take that number. Let's say we have 7 factorial. And we're not like 7, like excited. We're just 7 factorial. What that means is you do 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what factorial is. The only weird one is 0 factorial. 0 factorial is 1. That's very odd. So like 2 factorial would be 2 times 1. 3 factorial will be you start at 3 and work your way down to 1. So that's what factorial means. There is a button on your calculator. It's even on the calculator. I double checked. Calculator. Um, you hit math. Let me pull my calculator up. In fact, I'll pull my notes up side by side for you. Here we go. I'm getting there. There you go. So if you want to do factorial, so I'll do 7 factorial. You hit 7. Let's clear that out so we have a new screen. 7, and then you hit math. Then you go over to probability. And you can see that, yay, number 4 is factorial. So when I hit enter, it does 7, and or you can just do it by hand. I mean, if you don't trust it, some of you are funny. You're like, I don't trust the calculator. So you can do it by hand if you want. You're going to get the same thing. And then if you do 0 factorial, just to prove, oops, number 4. There you go. You get 1, just like I promised that you would. Okay, so oh, and this one right here. So sometimes permutations, remember, permutations have order. Order is great unless there's something that repeats. Like if you have, like my last name's Langeli, right? Langellii. Like enough is like how many different ways could you order my letters in my last name? Well, we'd have to count our letters. 1, 2, 3, 4, 5, 6, 7, 8. That would go 8 factorial in the top. But then you see these? These are the repeats. So how many L's do I have? So I have, in my last name, I have 3 L's, right? So to get rid of, so even though you're like arranging them, right, you're gonna have like a repeat because like if the second and the third L switch, it's still the same arrangement. So you do you do 3 factorial because there's 3 L's that repeat. And let's see, what else do I have? I only have 1A, 1N, 1G, 1E, 1I. So this is how you would solve. You would do 8 factorial and divide by 3 factorial. And so there are 6,720 different arrangements of the letters in my last name. And there you go. So I want to show you, because I feel like I'm going to let you use your calculator, but how does the math play out? So let's say that we have a combination. Let's say we have 7 students and I need 5 of those students to help me with something in my car. Well, that would be a combination. So let's follow the combination formula. So this is 7 is n, 5 is r. So the formula says n factorial, so 7 factorial over, so it's n factorial over n minus r factorial times another r factorial in the denominator. So if I do n minus r, that's 7 minus 5, right? So that would be 2 factorial. And then another r factorial, r is 5, so I would need an extra 5 factorial. That gets rid of the repeats within the groups. And now when I type this on my calculator, I want you to type it in like this. Now I'm going to actually work the entire math out. You're not going to have to do this in every problem. It would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 5 times 4 times 3 times 2 times 1. And like you could even, maybe some of you are like, oh, I remember that rule that if like you have 5, 4, 3, 2, 1 on the top, 5, 4, 3, 2, 1 on the bottom cancel. And you can say, oh, that's just going to be 42 over 2, which is just 21. Now let's go ahead and show you how this works on your calculator in the same way, okay? So let me dual screen with our calculator here. And if you choose to put this part in your calculator, you'll put parentheses around the double stuff in the denominator. So if I do 7 factorial divided by parentheses 2 factorial 5 factorial, you get 21. So I am very happy if you get to this step here and then you can type the final, and then you can just give me the final answer. That makes me very happy. Now, I want to see probably at least that much. I'll let you know if that changes, but I also want to show you your calculator has something else really cool in it. You can just type the this part in there. So watch, type the 7. I hope, and pull your calculator up right now, just in case, pause the video and get your calculator. So do 7 and then hit math, go over to probability. And I was really surprised that this was in the free version of calculator. Look at number 3. That's the combination. So if we hit enter, you're telling your calculator 7 is my n value and my r value is, now go ahead and hit 5. Hit enter and you get 21. So your calculator will do all the math for you. Now, I feel like it's my job as your teacher to show you how the math works out, okay? As a math teacher, I should show you how the math plays out. So let me show you a permutation one. So permutation is n factorial over n minus r factorial. And so if this is n and this is r, there will always be more permutations if you use the same number than there are combinations because you're arranging all of the different groups. So I would do 7 factorial over 7 minus 5 is 2 factorial which if I wanted to like show you the really long way, it's 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. And like, as a math student, I'm sure you see 2 times 1 cancels with 2 times 1. So you could do, whew, that would still actually be a lot. That's going to be a big number, isn't it? I'm not going to do that in my head. I'm not even going to pretend. Let me zoom in. Ready? So let's type 7 times 6 times 5 times 4 times 3. I don't need 2, 1. So the answer is 2,520. But what's really neat is that you have two other ways of putting this in your calculator to verify if you're right. You can just do 7 factorial divided by 2 factorial, and you get the same thing. Or remember your calculator, I'm so surprised this is in the free version. You can do 7 math, go over to probability, select number 2 for permutation, 5 for R, so 7 for N, R is 5, permutation, you get the same thing. So I wanted to make sure that as your math teacher that I showed you what I want to see in green there and what I want to see, obviously the answer, but that your calculator does such a nice job at giving you the final answers. So let's just practice with the calculator and the setup one more time, okay? So combination, if we're taking a group out of a group, so we have, oh, I bet permutation won't allow us. I bet it will be too big. But let's say this is N and this is R. Remember, combination is N minus R with an extra R. So that would be 30 factorial over N minus R. Well, that would be 30 minus 2, so 28. Factorial. I don't know why I put those parentheses on. It's not needed since I'm doing the subtraction. And a 2 factorial. Now there's a chance this might be way too big for your calculator. That's a really large number. Oh, P.S. You can't do 28 times 2 factorial. You have to do 28 factorial and 2 factorial separate. Don't try to put those, like you can't like put factorials together like that. You can't do multiplying them and then apply the factorial. So let's do 30. Oops, 30. And then let's get our factorial. That's number 4, divided by, use parentheses here. Oops, let me hit delete. 28 factorial. Kind of nice. We're taking a break from all our like crazy algebra, right? Let's go do algebra. Let's do that. Oh, that's not so bad at all. Silly me. I was thinking the opposite. Um, sorry, guys, I was being kind of silly. So 30 factorial divided by 28, 2 is 435. Now I could apply this. I could just make a word problem out of this. This would be like if I have a group of 30 people and I need, how many groups of 2 exist within 30 people? So only 435. Let's do permutations. So that's n factorial over n minus r factorial. So that's going to be 30 factorial over 28. Notice it just doesn't have the extra bit down there. So 30 factorial divided by 28 factorial. There you go, 870. So that would be like, how many different ways can you order 2 people out of a group of 30? So again, pretty nice. Don't forget that your calculator, for right now, I'd like to see at least this along with the final answer when we approach the problems today. So on the next page, I have all the formulas we need, including the repeat formula up there. And let's see if we can decide if it's permutation or combination. So let's read number 1, or the first one. Find the number of words, with or without meaning if they're real words or not, that can be formed with the letters of the word chair. So what I want you to notice about the word chair is that there's no repeats to worry about. And it looks like we're going to be arranging. I hope you can it says find the number of words with or without meaning. So what we need to kind of acknowledge here is that we're ordering the letters. So because we're ordering the letters, we're going to use permutation. So I'm going to write a P, and I got to count how many letters I have. 1, 2, 3, 4, 5 letters. And it looks like it's implying that we need to order all 5 of them. It doesn't say like order 2 out of 5. It says just order them or find the number of words, which means find the orders. So let's apply our formula. Oh, that's going to be odd, huh? 5 minus 5 on the bottom. So that's going to be 0. If you want to, you can just make the bottom into a 0. And then I can get my calculator pulled up. It'll be 5 factorial divided by 0 factorial. Remember, 0 factorial is just 1. So if you guys are okay with it, I'm not going to divide by 0 factorial because I know it is 1. So there are 120 different words, fake or real, that can be formed from the letters in the word chair. All right. Fine. Now, when we go through these, it's really important. We have to decide, is order important or is order not important? Or is this like what we did yesterday? Because I did throw some of those in there. Find the number of words. To me, that sounds like there's going to be an order here, with or without meaning, that can be formed with the letters in swimming. Ooh, there are repeats in here. We got to be careful. So just like my last name, let's list the repeats. There's only one S, there's only one W, there's two I's, and there's two M's. So I'm going to show you how to do it when there's repeats and we're doing permutation. So we are going to do permutation, but we're going to use, so this is permutation with all the letters, but this one also includes repeats. So here's how we handle that. We do n factorial, so we got to count how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8. So we'll do 8 factorial, and now we have to put our repeats on the bottom. So I have 2 factorial, that one's for the I's, 2 factorial, that one's for the M's, and since I'm doing all the letters, I don't have to worry about R. So let's go ahead and get our calculator. That's going to be 8 factorial over 2 factorial, 2 factorial. Put those in parentheses for order of operations. 8 factorial, whoops, let's clear that out so we can see better. 8 factorial divided by, let's put the whole denominator in parentheses so we don't mess anything up. Now maybe you guys are like, I know 2 factorial is just 2. That's fine. I'm just safeguarding. That way, if somebody doesn't necessarily understand 2 factorial is 2, there you go. So there's my 8 factorial for my 8 letters. There's my 2 factorial for my repeats. So we're looking at 10,080. So there are 10,080 different arrangements of the letters in the word swimming. Okay, there, I'm going to keep that pulled up. There we go. How many, and I'll make it a little smaller. There we go. How many ways can you choose? Let's see. Choose 2 out of 4 kinds of flowers for a bouquet. Let's think about order. If you're going to choose roses and lilies out of a list of 20 different types of flowers, does it matter the order that you tell the person who's making it, the bouquet? Order really doesn't matter. You just want 2 out of 4. So I'm going to write no order, or order is not important. So that means we're going to do a combination. So let's see how many different choices we have. We have 4 different kinds of flowers. We're going to be picking 2 of them. So combination, I have the formula up there, is n factorial. So 4 factorial over n minus r, so it's 4 minus 2 factorial, and we have to put r factorial in the bottom. So if you're okay with it, I'm going to erase 4 minus 2. I'm just going to put 2 there because I know 4 minus 2 is 2. I'm going to type that on my calculator. So 4 factorial divided by, there's 2 things in the bottom, so please use parentheses, 2 factorial, 2 factorial, and I get there are 6 different combinations when you have 4 total and you're picking 2. How many different ways can a committee of 1 man and 3 women be formed from a group of 3 men and 4 women? This one's complicated. I'm just going to write that here, that this one's kind of a bit of a challenge. This one's a little complicated. Okay, the reason this one's a little bit complicated is because we have 2 groups. Okay, we have 2 groups, we have men and women, and we're being very specific about we want so many men out of so many men, and we want so many women out of so many women. So the most important thing is that the word committee doesn't really matter about the order, it's just the group of people. So I'm going to write no order. Because there is no order, this is definitely a combination problem. However, because there's two different types of groups that we have, and we want specific things out of those two different groups, this is a double combination problem. That's kind of mean, isn't it? So let's deal with the men first, and then we'll deal with the women, okay? So in the men, we have 3 men total, and we only want 1. And for the women, we have 4 women total, but we just want 3. So for every combination we have here, we have to multiply it by every combination we have here. So this is actually very interesting. We are applying the fundamental counting principle of our two different things, kind of like a shirt and a pair of pants, right? A woman and a man, like two different things put together, but in those two different things, I have a group that I'm picking from. So I have two different combination problems. So I'm going to be a little bit lazy here on a double combination problem. Let's go ahead and if you want to show your work, you know what? I'm going to because I said I was going to, so I'm going to show my work. This is for the men. So that would be 3 minus, I would do 3 minus 1 and a 1. And for the women, I would do 4, and then I would do 4 minus 3 and 3. Now I could type that all in my calculator. However, I think for right now, I'm just going to, since I'm showing my math work, I'm kind of happy there. I'm going to use the cheaters button. So for the men, I'm going to do 3 math. I'm going to pick combination, and I'm going to put a 1. Pause the video if you're not keeping up. That way you can use your calculator simultaneously. And I'm going to get an answer of 3. So for the men, there's 3 different options. I'm going to take my highlighter. I'm going to put a big 3 over that. Now let's do the women. 4 math over combination, number 3. 3 women we're picking from a group of 4. Hit enter. I have 4 here. So altogether, I have 3 different types of groups I can pick for the men, 4 different types of groups I can pick for the women. So I have a total of 12 overall committees together, the men times the women. All right, that was a challenge of a problem. It was a double combination problem. A male student is going on, not that that's that big for the problem. A student is going on spring break at Daytona Beach. He has 8 tank tops and 12 pairs of shorts. So those sound like, 2 totals. He decides he's going to need 5 tank tops and 6 pairs of shorts for the trip. How many different suitcases can he pack? So it's not just, if they didn't have this part here that I'm highlighting, if it just said how many different outfits does he have, he has 8 times 12. He has 96 different outfits. But that's not the question. The question doesn't say, hey, he's bringing all of his clothes. The question is, how many different types of suitcases could he pack, like a combination of those? So what I'm going to do here, guys, is, again, this is a 2-group problem. So the first group I have, and it doesn't matter if he puts his red one in before his blue one, right? He can put his blue one before the green one, after the red one. Order is not important, so I'm going to write no order. So let's talk about his tank tops first. So for his tops, he has a total of, this is a combination of tops. Remember, order is not important. He has 8 tank tops altogether. And how many is he taking? 5. It says that it's going to take 5 tank tops. Now for every top that he takes, we have to multiply that by the shorts. So let's see how many shorts he has. He has 12 in his drawer, but he wants to take a group of 6 of them. If you can ever use the word group, you're in combination, not permutation. Now I will set each one up. Fraction for tops, fraction for shorts, 8 factorial for tops, 8 minus 5 factorial on the bottom with an extra 5 factorial. And then for shorts, 12 factorial, 12 minus 6 factorial, and an extra 6 factorial because we're in combination. Permutation would not have these extras, but combination does. Now I can type that in my calculator, or maybe I'll just take a little shortcut and do 8 math. let's see, I need C, so I'm pick number 3 and 5. So this is for the tops, 56 tops. So I'll do 56 with my highlighter times 12 math and 6. Oh, silly me, I need to pick combination. So pick number combination. Now put in a 6. 924. Ooh, it's going to be a lot of different outfits he could pack, huh? So we'll do 56 times 924. Wow, that is a lot of different suitcases he could pack for his trip. There you go, 51,744. Oh, you guys are doing great. I hope that this is coming together a little bit. I personally believe picking between fundamental counting principle, permutation, and combination is probably the hardest thing overall. In how many different ways, and if you guys are kind of like, oh, I need a break, pause the video, go get a cup of coffee, get a Mountain Dew, take a little rest, come back and finish the notes with me in a little bit. How many ways can a selection of 3 men and 2 women be made from 5 and 5? Now that is different, right? Yes, this is actually going to be the same thing as the other one. So what I'm going to do is I'm just going to skip by that one because we've done one just like that. And if you want me to email me and ask me, I will tell you the answer. You could honestly probably copy and paste it into Google and get the answer. How many 4-digit numbers are possible if no digits are repeated? So when I think of a 4-digit number, I'm not thinking combination permutation. That sounds really familiar to fundamental counting principle to me. Hey, by the way, permutation, if anybody is thinking that permutation and fundamental counting principles sound very similar, they actually are. Permutation is just a shortened version of fundamental counting principle or a different, like it uses that concept. Anyway, when I talk about 4-digit numbers, that brings me back to yesterday's notes, at least in my head it does. Fundamental counting principle. So I have 4 different digits and no digits are repeated. So I know like my digits range from 0 to 9, right? That's 10 different digits. 10 different digits. We talked about this. So the first number, I have 10 options. When I make my second, because there's no digits that are repeated, I'm down to 9, then 8, then 7. Now, if any of you want to try the permutation of 4 and 4, or I guess that would actually be 10 and 4 because you have 10 different digits taken 4 at a time, you might actually realize this is the same thing. But I like, when I talk about different digit numbers and passwords and stuff, I just like the fundamental counting principle. So I'll do 10 times 9 times 8 times 7. So there it is, 5,040. And that is with no repeats. Remember, if there were repeats, if repeats were allowed, so if we had repeat, I didn't spell repeats right. You think I'd be embarrassed, but I'm not. If repeats were okay, then it would be 10, 10, 10, and 10. How many different ways can 4 patients be assigned to 6 hospital rooms so that each patient had a private room? So, excuse me. So something that I'm thinking about is like, does it matter like what room goes to which person? I'm gonna have to say yes because like you're giving them a specific room. I'm gonna actually write that down. This is giving them a specific room. It's kind of like giving them a different job. That's a permutation. So like if you're in room 504, that's different than being in room 500. So I'm going to do permutation. Let's see. I have 6 rooms and I'm going to be using 4 of them. So permutation does 6 factorial over 6 minus 4 factorial. So what I do is I think to myself, like, if you rearrange it, like if person 1 switched rooms, would that make a difference? Yes, it would. So that means it would be permutation. So let me get, that's really just 6 factorial over 2 factorial. So you can work this out the long way, the short way. As long as I see this or this and your final answer, I'm pretty happy. But please don't skip one. You got to put at least one of those 2 down for me. So I do 6 math, and then I'll do permutation 4. So 360. There you go. That's a lot. Like, you think about that. Like there's 6 rooms and 4 patients. There's 360 different like seating. If you want to also like take it back to like a seating chart, by the way, that would be a permutation. And like assigning a hospital room is kind of like a seating chart. I can't believe there's 360 different ways to do that. That's crazy. Now, there's your challenge. If you want to, please go ahead and try it. I'm just going to go ahead and move on. I gave you the answer in that one. Let's talk about this manager. A manager must select 4 employees from a promotion. 12 employees are eligible for this promotion. How many ways can the 4 employees be chosen? So it doesn't really sound like the promotion. They're just talking about a promotion in general. In this part, don't read number 2 yet. If you already read number 2, you're probably going to get confused. In this part, it doesn't look like order is important. Like they're just, like it's not like if I pick you first, you get a better promotion. It's just they all get the same promotion. Since they all get the same promotion, that's going to be a combination of people, 12 total, and we're picking 4. So that's 12 factorial over 12 minus 4 factorial with the extra 4 factorial in the bottom. Remember, combination does the extra little part in the bottom. So let's go ahead and may as well just use that little cheating feature in our calculator. Let's say it's going to be combination, and that's going to be a 4. So I get 495 there. Pretty cool. All right, now let's take a look at the next problem. Oh, it's the part of the same problem. And how many different ways can those 4 employees be chosen to be placed in 4? Oh, look at this, different jobs. So this time the promotion is different for each person. Like if you get assigned to like, the front desk, that's different than being assigned to, somewhere else. So different jobs means that it's not the same. It's different. In fact, order is pretty important. Order matters, so this would be permutation. So we use the same numbers, but we do not put the extra 4 in the bottom for permutation. So you can type that, or you can type the other way in your calculator. Hopefully my calculator is showing up well for you on your notes. And there is definitely going to be more for this one because each group has a different assignment. All right. A sample of light bulbs is randomly selected from a batch of 15. How many different samples are possible? So what we need to think about is order. We're just talking about like a group of 3 light bulbs, right, to be sampled. There is no order implied in this one. Like it doesn't matter which one I pick first. So that would be a combination of 15 and 3. So it'd be 15 factorial over 15 minus 3 factorial with the extra 3 in the bottom because combination does that. So 15 combination and 3. So 455 different samples. Whew. All right, my next class is just about to get started, so I have a few more. They're going to go pretty fast, but I'll do the next ones in another video so I'm not late to my class.